Dear students of the General Secondary Certificate, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to your program Madrasa ala al-Hawa. Today, inshallah, we'll continue our revision about the syllabus of chemistry. We wish you all the best of luck. Firstly, I need to welcome with your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Actually, a lot of students think about the problem that you give them in the previous session, and we need you to solve it with the students. Okay, could you remind us with this problem?
Okay. I said that 74 gram of calcium hydroxide dissolved in 1 liter of water and added to 72 gram of hydrochloric acid, which dissolved also in 1 liter. The question is this solution, is this mixture between the two solutions, is acidic or alkaline? We must at first write the balanced chemical equation. HCl and calcium hydroxide, it gives calcium chloride plus water. I said the balanced equation, so 2 because the calcium divalent and 2 for water. In this reaction, 2 moles of HCl react with 1 mole of calcium hydroxide. So we want to know the number of moles in each one. Given that calcium, we know that calcium equals 40, chlorine 35.5, O 16, and hydrogen 1. So number of moles in HCl 72 divided the molecular mass of HCl 35.5 plus 1, which is mean 36.5. Must react this 2 moles 2 times 72 divided 36.5 must be react with 1 mole, which is the molecular mass of calcium 40 plus OH 16 plus 1 17 by 2 34. So the problem must be as follows: 2 mole of HCl, 2 moles, 2 times 36.5 must be react with 1 mole, which is 74. So 2 moles of HCl will be 71, and 1 mole of calcium hydroxide 74. But here we use 72 of HCl, 72 of HCl. So acid is more in this reaction, more than calcium hydroxide. It is more than calcium hydroxide. So in order to get the number of moles of HCl and the number of moles of calcium and the difference between the 2 moles, we can find the difference in calcium hydroxide. So I can divided 72 of HCl divided 71 and 74 divided 74. I say that we take the same volume. So the ratio between the moles equals the mass of H1 divided the molecular mass. From this reaction, so 74 divided 74 equals 1, but this is less than 1, and the difference between them gives that calcium hydroxide more number of moles than HCl, so it has alkaline effect. Okay, this is the idea of these problems.
But actually it was a great problem, has a lot of ideas.
Yes.
Thank you. In the last session we stopped at question number 2 in the exams of the General Secondary Certificate for the first session 2014.
Yes.
Actually, this exam was full of a lot of questions, so we need to continue its solving, please. And then after that, we'll make the revision as you advise our students from the challenge questions of the book and the evaluation.
Yes.
Then we'll solve these questions, inshallah, later on in the next sessions.
Okay.
Okay, let's continue first session exam 2014. Okay, he said that compare between complete and reversible reactions. Sorry for starting. I need you to learn, our students, how to answer the question, not only to write the information, how to introduce it to the examiner to have the high marks, inshallah.
Okay. This is about complete reaction, incomplete reaction. From the definition of the two terminology, we can find how we can know how to make a comparison. Complete reaction, which means reaction proceeds in one direction, while incomplete reaction, the action proceeds in both forward and backward direction. The number one in the comparison, the definition from complete reaction, which proceeds in one direction, and this proceeds in two directions, forward and backward, proceeds in forward and backward. Number two, I give example for each one. When I say magnesium react with H2SO4, when magnesium, the metal, react with acid to form salt, and the hydrogen evolves, magnesium sulfate. So hydrogen go out from the medium, so this reaction cannot, the products cannot react with each other to form the reactants once more. So we call this is a complete or a reversible reaction. يبقى this a reversible reaction which proceeds in one direction, one escape from the medium. And this is example. Here's the complete reaction. When I get nitrogen and hydrogen in closed vessel, it gives ammonia gas, nitrogen gas, hydrogen gas, ammonia gas. And this is can proceed forward and backward reaction. Okay, this is about the two examples.
Okay, thank you. The next point is complete between or compare between neutralization and hydrolysis. Actually, we need the size of the font. Yes, to make a font size bigger, please.
Neutralization we know that neutralization, reaction between acid and alkali to form salt and water. Example, sodium hydroxide alkali react with HCl acid to form sodium chloride and water. So neutralize the reaction between acid and alkali to form salt and water. Opposite of neutralization is hydrolysis. Hydrolysis. So hydrolysis means that salt dissolves in water to form acid and alkali, from which the salt is derived. For example, when I get ammonium carbonate NH4 CO3 dissolved in water, we take 2 molecules of water to form ammonium hydroxide plus 2 ammonium hydroxide according to the balance plus H2CO3 carbonic acid. This is the comparison between the neutralization and hydrolysis.
The last point of comparison is compare between primary cells and secondary cells.
Primary cells, it is a galvanic cell in which cannot be recharged, can't be recharged. can't be recharged. We say that it has irreversible spontaneous reaction. Irreversible spontaneous reaction. And the last point, example about the dry cell. Dry cell cannot be recharged. While secondary cell, this can be recharged, So it has reversible spontaneous reaction, such as L-carbatal. Yeah, 3 points in this comparison.
Actually, how could the students know how many points they have to write? Or do they write all the information that they know in the comparison, or make it a limited number of points?
If the comparison has limited points, such as this one, neutralization, hydrolysis, primary or secondary, and can write from the definitions and the difference between them in this definition, and I give example. And maybe it contains 2 or 3 points only. But when the comparison has many points, such as compare between the organic and inorganic, I think in the exam it gives the main points of the points which view to make this comparison.
Thank you. Let's transfer to the next question, please. Third
Yes.
question, said that what's meant by ferriones, mention their uses and their environmental harmful effect. Actually, dear students, I need you to pay attention for the following. The question have a lot of points to be answered in the same line. So please underline the points that you have to answer, such as, for example, here he needs the definition of ferriones, the uses, then the environmental harmful effects. All of these points to be covered, just underline them to know that you have to answer 3 points, to not miss any of these points, okay? Then we need the definition, the uses, and the environmental harmful effect.
Ferrione, it is the fluorochlorocarbons, compounds of fluorine, chlorine, and carbon, such as ferrione, fluorochlorocarbons, such as carbon tetrafluoride or carbon dichloro-difluoro or dichloro-difluoromethane. This is about the compounds of ferriones. The uses of ferriones, it is used in refrigerators and air conditioners for cooling. Number 2, used in spray substance such as perfume or insecticide, whatever. Number 3, it is used, or they are used in cleaning electronic cells. In cooling in refrigerators and air conditioners. Number 2, in spray substance. Number 3, in cleaning electric cells. But ferrione has bad effect on the environment because it causes decay of the ozone layer. So we know that in 2020, ferrione will be replaced by another ferrione which is more more easy or less harmful to the environment. This is about the ferriones, uses and effect.
Okay, the next point is write the equations for preparing ethene or ethylene in the laboratory, mentioning the condition of the reaction. Actually, I have here, he said write the equations. We know that the preparation of ethene happened on 2 steps, and we have a summarizing or a total equation. The student should write here in the preparation all the equations. Since he said that, write the equations. Or he may write only the sum or the total equation.
The 2 are correct, but it is easy to write only one equation. Whatever he write equations or equations.
And when the student have to write the whole equations.
Yes.
When he
there is no I, I don't explain how the examiner don't ask the student to make the two
Reaction
equations
mechanism
أو
or-
mechanism of the reactions.
Oh.
I think there is no any questions in the last exams about I would say about mechanism of
No, no,
reaction.
no, he didn't mention the mechanism.
Okay.
So the student tried the mechanism if he had asked it
He
to.
want to write exam.
Yeah.
But I think it is easy to write the final equation. But I will explain the two equations. But I myself advise student to write only one equation to be easy for the students.
But if he write the 3 and the sum is right and the 2 are wrong, he will have negative marks for the wrong
We take
equation.
the last one. We take the last one. The
No,
final.
we know that يعني the examiner looked to the last one
The
only.
final. Okay. The final.
Okay, thank you. I'm sorry for interruption.
Okay. Number one, we get C2. We want to get C2. We get ethanol, C2H5OH, ethanol, plus sulfuric acid, H2SO4. At 80 degrees Celsius, it gives ethyl hydrogen sulfate and water. This is the first step. Then ethyl hydrogen sulfate, C2H5HSO4, at 180 degrees Celsius, it gives C2H4 and H2SO4 evolves. So the two equations will be in one equation C2H5OH ethyl alcohol 180 degrees Celsius. It gives C2H4 plus water, and this go ethyl hydrogen sulfate with ethyl, sulfuric acid with sulfuric acid. What about sulfuric acid? Sulfuric acid H2SO4, I write it on the arrow. So the final equation will be ethyl alcohol C2H5OH, H2SO4 at 180 degrees Celsius, it gives C2H4 plus water. The three equations are correct. If you write only the last one, it is also correct.
Thank you.
Okay.
The second part of the question said that the lead acid battery is developed and becomes the suitable kind of batteries in cars. Show by drawing with label diagram its structure. Then write the total reaction for the battery. So he needs a label diagram, then the equation for the battery.
Okay.
Okay.
Here two parts are two drawing. Number one, I write the network of anode and the cathode. It is network of lead. This network of lead. Number one, lead, BB, this of lead and that's of lead. Number one, this is full of paste of lead, BB. And the second, this act as anode. And the second full of paste of lead dioxide, BbO2, this act as cathode. And then these leads, H1, anode and the cathode, make a one cell. The battery has 6 units of this. H1 gives 2 volt, and the total EMF of the battery, of the car battery, equals 12. 6 by 2 equals 12. So I write the container which has anode and the cathode, the 1, 2, anode and the cathode, 3, I said 6, 3, 4. We can write the 6 all, we can write 4, 5, whatever, but the meaning is correct. 1, 2, 3, 4, 5, here 6, 1. This container is made of polystyrene or antimony lead. it contains H2SO4. And we can connect the anode together to be negative pole of the battery, and the positive cathode are connected together to form the positive of the battery, the cathode, and this is close the battery. This is about the drawing. So by number one, I make the anode and the cathode to find the structure of H1, the components of H1, and then I make the body of the battery, which contains sulfuric acid and this lead. This is about the drawing of the car battery. About the reaction, lead Bb plus lead dioxide BbO2 plus 4H positive ion. This is the sulfuric acid, 2SO4 negative 2. Discharge, it gives 2BbSO4 plus 2 water. And this recharging, we know that car battery can be recharged. So the equation will be lead plus lead dioxide plus 4H positive plus 2SO4 negative. This charge gives 2 lead sulfate, 2 BbSO4 plus 2H2O. This is about the equation of the car battery. What else?
The next question said that what's the role of the following scientists in chemistry? Le Chatelier,
Le Chatelier make a principle to find the effect of change condition such as concentration, temperature, pressure on the direction of the reaction at equilibrium. The Le Chatelier principle states that changing in any condition of the chemical equilibrium such as concentration, temperature, or pressure will shift the equilibrium to the direction which will oppose this change. Change in any condition, again, change in any condition of the chemical equilibrium. يبقى عندي change on the chemical equilibrium such as concentration, temperature, pressure will shift the direction of the equilibrium, to the direction which will oppose this change in order to return to its equilibrium. The second one,
Avogadro.
Avogadro make Avogadro's law to make the relation between the volume and the number of molecules. He said that equal volume of different gases at the same condition of temperature and pressure have the same number of molecules. Equal volume in the same condition of gases in the same condition have the same number of molecules. Take care the difference between Avogadro and Gay-Lussac. Avogadro about the relation between the number of molecules in different volumes or equal volumes in different gases. But Gay-Lussac said that the volume of gases involved in the reaction and the gases produced from the reaction are exist in a fixed ratio. This about the relation between the volume and number of molecules يبقى Avogadro. About the volume of gases and product and reactants will fixed ratio يبقى ده Gay-Lussac. The third one,
Ostwald.
Ostwald makes the relation between the degree of dissociation, degree of ionization of a weak electrolyte and the concentration. It states that degree of dissociation or degree of ionization increase by dilution. So Ostwald's law makes the relation between concentration and degree of ionization. Again, Ostwald said that degree of ionization increases by dilution or decreases by increased concentration.
The last question in second part in question 3 said that a student prepared 2 test tubes. She put in the first one solution of sodium carbonate.
One, she put sodium carbonate in A2CO3.
And in the second test tube she put ammonium chloride.
NH4Cl, ammonium chloride.
Okay, she detected the solution by a blue litmus paper. She found that the paper retains its blue color in the first solution and turns red in the second solution. Explain by balanced chemical equation these results.
So you must know the effect of salts in litmus, if this salt is acid or base. So I'll mention you how to know the effect of these salts, and then I will write the equation. At first, this is the salt Pa. The first part is the positive, refers to the metal or the alkali, and the second part refers to the acid. This is referred to the base and this to the acid. If I found in the first part sodium or potassium, sometimes calcium and magnesium and calcium, they will be strong base. If I found sulfate, I said this will be positive and this is -2. Sulfate -2, or nitrate, or halide, chloride, bromide, iodide, this is strong acid. If I found this, the first part, the base, and I don't find the acid, it will be has basic effect. If I found one of these, the acid, and the second is not found, it will be acidic. If the two are found or two are absent, it will be neutralized. It will be neutral solution. So in the first one, sodium in A2CO3, here the sodium and carbonate is not found here, so it has basic effect. And the second one, NH4Cl, NH4 not found here, but Cl is found here, so it has acidic effect. This is to know in general how to say the effect of these salts. If it comes in the question as choose. But here we want to write
the details of this question. We'll answer it inshallah after having a break. Wait for us. Let's go to a break. Welcome back, dear students, after the break. Let's continue the details of how to answer this part of a question. Actually, this question is very important one.
Okay. I said that I say the two parts of the salt. If the first part contains sodium, potassium, magnesium, calcium, it will be a strong base. If the second part contains sulfate, nitrite, halide, chloride, bromide, iodide, it will be a strong acid. If the two parts are found, it will be neutral. Of the two parts not found, it will be also neutral. Here, sodium carbonate, I said that sodium is found, so it has basic effect. And the second one, ammonium chloride, so chloride is found, so it has acidic effect. But we want to write the equation. Maybe I can explain the mechanism by write the two equations, or I can write only one equation. It is easier to write one equation. Sodium carbonate in A2CO3 dissolve in water, HOH. So here we found two positive ions, sodium positive 1 by 2, two positive ions. So I take 2 molecules of water. Or carbonate has 2 negative charge. If I can know the number of water used in this equation by know the number of positive charge or the number of negative charge. Then sodium will take OH to be sodium hydroxide. I said that sodium hydroxide is a strong electrolyte. Means strong electrolyte means that it is completely ionized. So I can write sodium hydroxide as follows. 2Na positive plus 2OH negative, because it is a strong electrolyte. While H2 takes CO3 to form carbonic acid, it is a weak. Weak means that it is not completely ionized. Partially amount of this acid can be converted into ions. According to Le Chatelier, hydrogen combine with carbonate to form carbonic acid. The number of hydrogen ion in the solution decreases. So the reaction shifted forward to decompose more of the water to form H2 and OH negative. H2 combined with carbonate, and the amount of OH negative ion increase. According to Le Chatelier, concentration of OH negative ion increases, so it has basic effect. And this is why sodium carbonate, the blue litmus, is still as it. What's about ammonium chloride? Here the positive one, ammonium, or positive negative chloride. So I take a 1 molecule of water. Ammonium hydroxide, it is a weak electrolyte, not completely ionized. I will write it NH4OH, ammonium hydroxide. While HCl is strong hydrochloric acid, it will be H positive, Cl negative. Also, according to Le Chatelier, concentration of H positive ion increases, so it has acidic effect. Why? H positive ion increase. I said that OH combined with ammonium to form ammonium hydroxide, weak electrolyte. Concentration of hydroxide decreases. According to Le Chatelier, more water is dissociated to form a positive hydrogen ion and the negative hydroxide. Hydroxide combined with ammonium and let hydrogen ion to increase in the solution. So increased hydrogen ion means that the solution is acidic or has acidic effect. This is why ammonium chloride turns litmus into red. Okay.
Question number 4 said that what's meant by titration?
Titration.
Sorry, I need to know something. What's meant by? What's the difference between what's meant by and define? Or both the same, or what?
I will. What is meant by and define? At the end, the two are the same. But define when we have a text, such as law of Le Chatelier principle, or law of mass action. It is defined between two quotations. We make the definitions. I can change some words, but what's meant by, it has no definite text. I know what's meant by titration. No, here is a definite text. But what's meant by, when I want to ask about something which is not have a definite text. Titration, this is a reaction between unknown substance and the known. Unknown concentration of substance and standard solution. This is why, in order to get the concentration of unknown substance. So the titration means that make the reaction between solution we want to know its concentration with another solution we know its concentration. We call it the standard solution. And from the reaction and using the law, which is M1V1 divided MA equals M2V2 divided MB, by this rule we can find the volume or the concentration of the second solution. So titration is the process used to find unknown concentration of solution using a standard solution.
The next point, what's meant by indicators?
Indicators. Indicators such as litmus or methyl orange, or this is substance has different color in different medium. يعني they have different color in acidic, another color, a color in acidic, another in neutral solution, another in basic solution. So indicators has different colors. We can use the indicators to define the solution of it's acid, base, or neutral. Also, we can use indicator to find the end point in neutralization process when we make the reaction between acid and alkali. For example, we want to find the titration to find concentration of 1. We make neutralization or titration between acid and alkali. At the end of the reaction, at the complete reaction, we know using indicator. So we can say indicator by 3 terms, whatever, each one is right, is correct. It is a substance change its color in different solution, acid, base, or alkali. Number 2, it is used to detect the type of the solution, if it is acid, base, or alkali, or neutral. Number 3, we can say indicator, it is a substance or solution used to detect the end point of the reaction.
The last one in the what's meant by ionic equilibrium.
Ionic equilibrium. From the definition, ionic, this compound must be ions, and equilibrium. It is the equilibrium arising in weak electrolyte. This is why, because the weak electrolyte can be differentiated, can be dissociated into small ratio of ions, and another amount of the substance remains. So two side substantial ions and the molecules. So definition of ionic equilibrium. It is the equilibrium arising between weak electrolyte, molecules of weak electrolyte, and its ions, or the ion resulting from it. Equilibrium between molecules and the ions, without طبعا the words weak and weak electrolyte.
Then the second question in the first part, in the fourth question, said that ethanol is used in many industries, such as converted alcohol, perfumes, and alcoholic liquors. What are the additives provided to ethanol to become a converted alcohol, and why they are added?
What are
additives?
Additives. Number two.
Why they are added?
Why? There are 2 points. We say that converted alcohol, or it is called red spirit. Red spirit. We know that ethanol is used as a fuel, is used in perfume, is used as solvent, and used in thermometers. Many uses of ethanol, but also it can be used as a liquor. In order to make the ethanol is a substance used for fuel and not used for liquors, we add some substance, such as poisonous substance. Ethanol added poisonous substance, such as methanol. It causes blindness and madness. Also, bad smell substance, bad smell, such as pyridine or palm oil, and dyes. This is why red spirit has red color. Ethanol, poisonous substance, and bad smell substance, and dyes. This mixture and some water. This mixture is called converted alcohol or red spirit. This can be used as a fuel, but we cannot use it as a liquor due to the presence of a poisonous substance and bad smell. And this is difficult to be separated from each other and illegal to separate them. This is about the converted alcohol. And why I said that, in order to be used as a fuel, as a solvent, but don't use it as a liquor. This is called converted alcohol.
Number B, illustrate how to detect taking of the drivers for liquors.
Okay. We get a balloon. We let the driver blow up the balloon. This balloon contains silica gel in the neck of the balloon. Silica gel weighted with K2Cr2O7, potassium dichromate, acidified by little of sulfuric acid. Acidified. It has orange color. Orange. So the neck of the balloon will be orange according to the presence of K2Cr2O7 acidified. And let the driver blow up the balloon. The exhaled gases enter the balloon and let the exhaled gases of the driver goes out. When the color of potassium dichromate change from orange to green, so the driver is drunk. If the color change from orange to green, this is why. And we can use another substance. I said that potassium dichromate oxidized ethanol, oxidized alcohol to aldehyde then acid. So, and the color of potassium dichromate change from orange to green. So when the color of the neck of the balloon change from orange to green, so the driver takes drunk, or it is drunk. We can use KMNO4, potassium permanganate, which has violet color. It will oxidize the ethanol and change into colorless. So we may use KMNO4 or use K2Cr2O7. Again, we let the driver blow up a balloon contains silica gel weighted with potassium dichromate acidified. When the color change from orange to green, so it has, so the driver takes drunk. If it is not, so it has no drunk. This is about how to test for driver if he is take a drunk or not.
Illustrate by a practical experiment how to test for carbon and hydrogen elements in an organic substance.
Okay. When I write about the equations, so I write I draw the apparatus, label apparatus, and write the equation. We get burning tube contains organic substance, maybe starch, maybe a piece of bread, maybe hair, whatever, from a living organism, and copper oxide. And let the gases passes on anhydrous copper sulfate, CuSO4. Without water, it has blue color. It has white color. Turns blue when it takes the water. And then let the gases pass in clear lime water. Test tube contains clear lime water. And here the flame. My mistake. I will draw pi using rule. And let the tube closed. And then we must take a holder. Don't leave the apparatus in the air. And here clear lime water. So the drawing, get a tube, burning tube, contains organic substance such as piece of bread or starch, and copper oxide, which has black color. And let the gases passes on anhydrous copper sulfate, which has white color, and passes in clear lime water. The copper sulfate turns from white to blue, indicates the presence of water. When it turns from white to blue, this means that it takes water. And lime water turns from clear to milky, so indicates that here is carbon dioxide. So the reaction will be hydrogen, which is found in the organic substance, plus water, plus copper oxide, by heating.
Sorry for interruption. I have a question here. This experiment is done to detect that the substance is organic and to detect the carbon and hydrogen in it, or to distinguish between organic and the inorganic. I mean, the question will come into the students, how to detect the carbon and hydrogen in the organic, or how to differentiate between organic and the inorganic.
Actually, it is a difference between detection and differentiation. When I say how to detect the presence of carbon and hydrogen in an organic substance, I know that it is an organic substance, but I want to know if it contains carbon and hydrogen or not. But when I say how to differentiate between, for example, ethane and ethane, there are two gases, but I don't know which is which.
So the experiment here said that we know that it's organic substance, just we know to detect the carbon and hydrogen in it.
Yeah.
Sorry for interruption, we stopped at by heating for detection of hydrogen. Then the hydrogen with the copper oxide as oxidizing agent by heating. What are the products will be released here?
So hydrogen with copper oxide oxidized hydrogen to give water, which turns copper sulfate into blue, and copper remains in the tube. Also the carbon, which is found in organic substance, react with copper oxide or oxidized by copper oxide to form carbon dioxide and the copper. Carbon dioxide, we know that because it turns lime water into milk. This experiment to prove that organic substance contains hydrogen and carbon. Okay?
Then the next question that we have is the second part of the fourth question, said that explain by an experiment the effect of dilution on ionization of 0.1 molar for hydrochloric acid, or hydrogen chloride, and acetic acid.
HCl and acetic acid, CH3, COOH. H1, 0.1 molar. And we want to know the effect, not to differentiate, the effect of dilution on H1. Take care of the equations. Here we have two solutions. HCl gas dissolved in water to form 0.1 molar, and CH3COOH acetic acid dissolved in water to form 0.1 molar. And H1 will be diluted, adding more water to be maybe the dilution or the concentration less than 0.1, or maybe 0.01, 0.001, whatever. And I want to know the effect. Of this dilution. Actually, we want to get an electric circuit. Contains a battery, K, and lamp, and here two inert electrode, maybe for carbon or from platinum. This is about the electric circuit, which contains battery, switch, lamp, and the solution will be here, and these two electrodes, inerts, in order to give no effect on the solution. At first I take 0.1 molar of HCl. We note that the lamp will give strong illumination. This is why, because HCl is a strong electrolyte. Strong electrolyte means that it is completely ionized. It will be 100% of the molecules converted into H positive ion and Cl. All molecules are converted into ions. So it gives a strong illumination. When I add more water, يعني converted from concentration 0.1 to 0.01, 0.001, we will notice that the lamp still gives strong illumination. So the dilution has no effect on HCl. The effect of dilution in HCl, dilution has no effect on HCl. How do you know? From the illumination of the lamp. Why? Because the HCl is completely ionized. When we put HCl in water, the all molecules are converted into ions. It is a completely ionized, strong electrolyte. When I use CH3COOH, CH3COOH, it is a weak electrolyte. It is dissociated partially into acetate ion and hydrogen ion. How we know? It gives weak, faint illumination. When the concentration of HCl equals 0.1, it gives faint illumination of the lamp. When we add more water, when we convert the concentration of the acid to be 0.01, we will notice that the illumination of the lamp increases. And when we add more dilution, more water to be more dilution, the illumination will be increased until we reach the very strong illumination. How can we explain this? We said that acetic acid is a weak electrolyte. Small ratio of molecules are converted into ions. So it gives faint illumination. When we add more water, by dilution, more molecules are dissociated in the presence of the water, which can break the bond between ions. So the number of ions increase, the illumination of the lamp increase. So the dilution of the acetic acid will increase the dissociation. Dilution has no effect on HCl and has effect on weak acetic acid. Okay.
Thank you, Mr. Muhammad, to be with us. It was a great honor and pleasure to be with you. Thank you, dear students, for being with us. We'll wait for you for the next session. I wait for your questions on our page on the Facebook. Assalamu alaikum wa rahmatullahi wa barakatuh.